Good afternoon. My presentation is on the growth of black holes. My name is Viviana Morales. I'm in Physics 1403, Section 66402, July 2015. Introduction. What are black holes? A black hole is a concentration of mass great enough that the force of gravity prevents anything from escaping it except through the Hawking radiation. The gravitational field is so strong that the escape velocity near exceeds the speed of light. This implies that nothing, not even light, can escape its gravity. This makes this object invisible to the rest of the universe, hence the word black. Supermassive black holes lurk at the center of every large galaxy. These cosmetic giants can be millions to billions of times more massive than the sun. Determining just how massive, however, has been daunting, especially for spiral galaxies and their closely related cousins, barrel spirals. And this illustration shows two spiral galaxies, each with supermassive black holes at their center. As they are able to collide and form an elliptical galaxy. New research shows that galaxies' dark matter hollow these merges and resulting growth of supermassive black holes. Every massive galaxy has a black hole at the center, and the heftier the galaxy, the bigger the black hole. There seems to be a mystery link between the amount of dark matter a galaxy holds and the size of its central black hole. Even though the two operate on vastly different scales, says the lead author Akosis Bogdag of the Harvard Smithsonian Center for Astrophysics. Previous observations have found a relationship between the mass of the central black hole and the total mass of stars in the elliptical galaxies. However, more recent studies have suggested a tight correlation between the masses of the black hole and the galaxy's dark matter hollow. It was not clear which relationship dominated. In the universe, dark matter overweighs normal matter. It holds together galaxies and galaxy clusters. Every galaxy is surrounded by a hollow dark matter that weighs as much as 1 trillion suns, extended from hundreds to thousands of light years. And the picture right here, this illustration shows the black hole pulling matter from the blue star beside it. The weak ultraviolet atomic emission and X-ray fluxes from the objects could be an important clue to the question of how supermassive black holes pull in matter. Computer simulations show that at low inflow rates, matter swirls toward the black hole in a thin disk. However, if the rate of the inflow is high, the disk can puff up dramatically because of pressure from high radiation into a torus or donut shape that surrounds the inner part of the disk. The usual balance between the inward pull of gravity and the outward pressure of radiation would also be affected. More radiation would be emitted in a direction perpendicular to the thick disk rather than along the disk, allowing material to fall in higher rates. The important implication of these thick disks, quasars, may harbor black holes growing at an extraordinarily rapid rate. As the material spirals through the disk towards the event horizon, it gains fantastic speed and releases vast amounts of energy. As a result, some of the disk materials does not fall in because its speed achieves escape velocity. This material is slung around one of the poles and expelled as a powerful jet traveling near the speed of light. So this shows the disk traveling at the speed of light. Astronomers have studied 51 quasars with NASA's Chandra X-ray Observatory and have found they may have represent an unusual population of black holes that consume excessive amounts of matter. core zones have supermassive holes that shine very brightly in different types of light. By examining the X-ray properties with Chandra and combining them with data from the ultraviolet and visibly light observations, scientists are trying to determine exactly how these large black holes grow so quickly in the early universe. The quasars in the study include 3 shown on the Chandra images in the graphic and are located between about 5 billion and 11.5 billion light years from the Earth. Conclusion: the growth of black holes. The current study and previous ones by different teams suggest that some quasars might have been more common in the early universe only about a billion years after the Big Bang. Such rapid growth might also explain the existence of black holes at even earlier times. The black holes are unique objects in the galaxy that may never be understood. Thus, this is now believed that black holes are not only common throughout the cosmos, but play a fundamental role in the formation and evolution of the universe we habitat in today. And these are my 2 references. Thanks for watching.